Good morning, Munadal. Today my talk topic is composition and entropy indirect noise generated in the subsonic non-isotropic nozzles and which is related to high-speed aerodynamics. After small introduction, combustion noise is an essential to affect the aircraft emissions. Noise oriented the combustion is an important contributor to overall the aircraft noise, particularly approaching and landing phases. Further, combustion generated sound can act as a source of thermistic instability, like consequences of which ranges from a decreasing efficiency to system failure. Modern premixed system designed on NOx emission can be particularly susceptible to this phenomena. And direct and indirect noise generations. In the work, we consider a multi-component ideal gas mixtures passing in the chamber eliminated within a nozzle. We assume a quasi-one-dimensional framework. The flow variables change because of area variations are assumed to be the constant across a cross section, so that the nozzle flow depends only the axial coordinate in the gas chemically frozen, which corresponds to the combustion situation in which the process is completely upstream of the nozzle guidance. Yet the compositional equivalence ratio are generated. The flow is assumed the adventure domain, so that the viscosity, heat, species, and the party forces are negligible. Gas is composed of n species with the mass fraction molecular and the chemical potential mu ion species are expressed in the terms of the mixture fraction Z. So I is equals to I into Z and have a frozen internal energy modes, so the heat capacity depends upon the mixture composition. This is a able to observe that the wave generation nozzle head in the opposite directions. Figure says that direct acoustic entropic and the compositional wave producing it the wave generator, and the indirect acquisition is generated by the excitation of an entropy and the composition distribution set to the nozzle for the downstream. Transfer function from a subsonic to supersonic. Subsonic to sonic compact nozzle. Indirect nozzle is generated when an entropic or compositional converted in a homogeneous accepted or accelerated or decelerated as when they passes through the nozzle or turbine blades. The total upstream and downstream propagates indirect pi and pi L waves are the areas of an entropic pi sigma and compositional nozzle and pi L. Marble and Candle 1977 considered the case of subsonic isentropic nozzle, that is a supersonic nozzle with a shock in the divergent section, where the total energy or entropy losses are localized viscous effect or accelerated to be. So the flow in the nozzle is modulating as invisibly. Isotropic, non-isotropic. Diagram the flow areas at the inlet A1 throat and A3 Z location AJ and outlet A2 of a non-isotropic nozzle with the stream illustration. The isotropic and non-isotropic gems can be linear and solved in the matrix form as shown in the above text. This enables us to compare a matrix of a transfer function from the inlet to the outlet of the nozzle, relating the variables across the section, where W equals to represents the input and output state vector. This way, the direct and indirect noise transfer function of a nozzle are determined. Effect of acquisition deflections. The theory Effect of co-accumulation reflection. The theory of framework presented the property X and A enables the amplitude of the direct and indirect acquisition values of pi and the pi plus L to be computed prior to the direct without experiments. However, the experiment effect of a repeated acquisition reflection must first be determined. The methods of used in the work extended the time-based model description by Roland to the frequency domain. This enables the source identification which by acquisition sources are extracted from a given pressure signal as the shown in consideration the acquisition of both upstream and downstream of the nozzle. Two one-dimensional chamber of the length L1 and L2 separated by the nozzle and upstream acquisition source at the location generated forward and backward propagation waves. Experimental setup. The analytical model present to and the enables us to make the prediction on and the indirect noise generation the model system. In order to validate those are conducted to the Cambridge view generator. In a configuration, the one described the dimensional those of experiments are presented in this section. Cambridge view generator is shown symmetrically. A primary flow of air filled into the precipitations are generated by the pulse injections of a secondary flow of helium, argon, carbon dioxide within perpendicular to the primary flow. Here is a diagram of a graphical represented experimental pressure fluctuations upstreams of a nozzle. A case E longs and C at C not too long wave plus duration contained exponential delay fit to exotic energy loss. Conclusion. The generation of an indirect nozzle is an isentropic nozzle is investigated and experimentally. The one-dimensional analytical frame developed consists of three components at lower order model to compute and explicit entropy. The generation of non-isentropic model developed the Dominic multi-component to account the relationship between the fixed source and the reversible system of resulting pressure traces. Thank you.